of difficulty as to the learning outcome of solving problems involving distance, velocity, and acceleration. That's the learning outcome for Physics 11. Well, I can give you a question everybody can get, and then I can give you a question nobody can get. So it's a nice happy medium as to the level of difficulty we give you here. Okay, so a g we talked about. G is the rate of acceleration on this particular planet. G here is 9.8. We're thinking G is going to be a little bit bigger than that for Saturn. Okay, what do I know? Always start with this. And on your quiz, you're going to get in a sec, there's questions worth 2 marks. And if all you show is an answer, I might give you 1 out of 2. If the answer is wrong, obviously you get 0 out of 2. Okay? Start with what we know. What do I know? When she drops her pencil, I got a distance of 5.05 meters. Is that in the unit I want, or did I got to convert something? That's what I want. I want everything in meters and seconds. Okay? If something's in kilometers or kilometers an hour, first thing you do is convert it. Okay? That's how long it took. That's the time. 0.95 seconds. Well, what am I trying to find out here? G. Look at the back of your book. You see any G's anywhere? No, but there's lots of A's. You got to know that's acceleration. When we're talking about planets, we're talking about G, okay? Because 1 G on Earth is 9.8 meters a second squared, and I showed you videos where we can have more than 1 G, okay? 5 Gs breaking a Formula 1 car, breaking in a Formula 1 car. Okay, half a G, you had problems like that where you're solving for the half a G. That would be 4.9, half a 9.8, okay? You might get some problems today where it says, what is that compared to G? How many times as big as 9.8? Is that acceleration? Okay, that's what I got. Is that enough? Do I know any velocities here? What formula am I going to use? Well, I got that one. And I know on your back of your book, it doesn't say F, it just says V, right? Okay, I got this one. Okay, I have this one. And I have some speed formulas. Okay, which one has D in it? Well, that one does, that one does, that one doesn't. Okay, do I have velocities? Well, what else do I know? She drops. Means this. What's the initial velocity right when I drop this thing? Nothing. 0. Okay, so yeah, we forgot something. VO is 0. That's free fall. When we drop something, we got to kind of know that. Do I have a final velocity? Maybe I could find it, but you know, do I care here? No, I could probably use this formula. D is VOT, but VO is 0 plus 1/2 A, and I know what T is, 0.95. Don't forget to square it. Okay. Oh, sorry, D I know, 5.05 is 1/2 of A. Let's use a decimal. So, again, do we want to solve this thing for A first, then substitute? Or do we want to put our numbers in and then solve for A? Sometimes if you put your numbers in first, it makes it easier, right? Because why on earth would I try to solve this for A when I can just get rid of that? So if I substitute a 0 in there first, it makes it a little easier. Okay, I want A by itself. So get rid of 0.5. Divide by 0.5, which is the same as multiplying by 2. Some of you guys will do that. That's fine. Okay? Same thing, right? That's gone. That's gone. So A is 5.05 divided by 0.5 divided by 0.95 squared. On. There we go. divided by 0.5, which is the same as timesing it by 2, divided by 0.95 squared. Whoop, come on. Okay. What's this again? Does it look reasonable? Calvin?
Yes.
What's it on Earth? G? 9.8. And we were expecting, well, a lot more. It's a little more. Does it seem reasonable? What are the units here? Meters per second squared. That's an acceleration. That's G. Okay? So, looks good. That's G on Saturn. Part B. How long until the pencil hits the surface, which is 175 meters away? Different problem. Okay. I know the distance is 175. I know that's the acceleration on Saturn. A, which is G, which is 11.2 meters a second squared. What else do I know? What's the initial speed? Still 0. I'm still dropping the pencil. I don't know the final velocity, do I? What am I trying to solve for? How long? Okay. Which formula do I want to use? Let's write the other ones like I got them on the back. That's just average speed. And if I combine these two, remember that's that formula that, you know, some of you guys tried to cheat and write on the back of your book, right? Just substitute that in there for V. That's about it, guys. What am I going to use? I need one with a T, so that kind of doesn't help me. Can I use this one? I got a distance. I'm trying to find a time. Is that just any old V? Yeah, now try to remember this. You can't use this because you don't know what the average speed is. Okay, it's changing. We have acceleration here. It's not just any old speed, and obviously if you put 0 there, the distance isn't 0, the time's not 0, okay? But don't use that guy because there's acceleration happening, unless you know what the average speed is. If you knew the initial and the final, then we could find the average speed halfway in between. Okay? What are we going to do? What can we do? Well, what else can we do? There's no formula here. Could I use this guy? Well, I know initial 0, so can I do this? D is 1/2 AT squared. Sure. Now, if the initial speed is not 0, and you have the whole formula, and you're trying to solve for time, that's called the quadratic. And some of you guys have done it, but a lot of you have not. It's possible. You can do it. All right? But in this case, I think we're okay. So again, distance is 175. Let's times it by 2 this time. Divide it by A. Now I know what A is. That's T squared. Okay? 2D over A, right? 2 times D over A. So T squared is 2 times 175 divided by 11.2. That's 31. 0.25 seconds, or do I have to do something else? Yeah, that's t squared, right? Not t. Take the square root of that. 5.6 seconds. Seem reasonable? Hard to tell because we've never been on Saturn. Sure, 175 meters. If you're on top of a building 175 meters tall and you drop something about 5-6 seconds to hit the ground, seem reasonable? Sure. Now, like someone else said, could you solve for the final velocity and then use that to solve for the distance? Sure. There's lots of ways you can do some questions. Okay, all the formulas will work. You can go around in circles and check every one. They should all work as long as you don't do something wrong. Okay, so that's it for today. One little example. I'll give you another one tomorrow, and that's pretty much it. The rest is just practice, practice, practice for the test. And some of you